The theory of the consumer is very foundational to microeconomic analysis. One of the key aspects that we often analyze when looking at the theory of the consumer is indifference curve analysis. And in fact, the other approach to the theory of the consumer is often done through equations that are based on the indifference curves that we will analyze in this session. So this is very foundational to intermediate microeconomics, basic economic theory of the consumer. First, what we'll do is we'll just get an idea of what an indifference curve actually is. An indifference curve is going to tell us a relationship between two different goods or bundles of goods that a consumer could potentially consume. So what we often do is we do an example in economics where we compare a consumer's preferences between guns and butter, or two other goods. Often actually it comes down to an analysis of, say, housing or whatever consumption we want to look at, and all other goods. So the relevant bundle of goods becomes one thing that's important, say our consumption of housing, and everything else. So one way or another we're going to compare two different goods and we're going to see where we're indifferent between the two. So what are indifference curves? Indifference curves, like we said, is a graph showing different bundles of goods between which a consumer is indifferent. You don't care if you have 5 apples or if you have 14 oranges. Those two quantities of goods or bundles of goods really give you the same amount of pleasure or utility as each other. So it's a graph showing these different bundles of goods where the consumer is indifferent between them. At each point on the curve, the consumer has no preference for one bundle over the other. Each point on the indifference curve gives the same level of utility to the consumer. So here we have an example indifference curve where we're comparing the consumption of shakes and pizza. All right, and we're going to highlight that on this indifference curve different points along the curve. You can see that points A, B, and C are all valued at the same utility. U equals 100 is what's given in this example. Anywhere beyond this curve or further out from this curve is going to be valued at a higher measure than the utility of 100 utils, or whatever we want to call it. So point D is going to be said to be more valued than points A, B, and C. A, B, and C were indifferent between all of those points. Point D is valued more. Point E then obviously would be valued less than A, B, or C, and given the curve there, it's also valued less than D. It's also very important to remember that we don't just have one indifference curve. It's not like some curve that has been plotted out from our measure of utility and that's the only curve. The utility curve is showing us how much utility we would get from different bundles of goods. Well, if the numbers of pizza or the numbers of shakes possible is very, very high, we have to take into consideration all the possible combinations. So we have to have a utility curve that exists when we only have one shake, and we have to have a utility curve that exists when we have 400 shakes. And so we have to realize that it's not one specific utility curve that actually exists, even though only one will end up being relevant within our analysis. But the fact is that there is really an infinite number of utility curves that exist. So for example, in this one we could look at an utility curve that gives us 75 utils, 100 utils, 125 utils, or 150 utils. And the reality is there's multiple utility curves in between each of these curves even. It's just our subjective preference from the consumer being shown as one particular line. But the reality is there's an infinite number of utility curves that actually exist. It's also important to note that because of our analysis and the way the logic of the situation that we have set forth, the model that we have set forth here, that our indifference curves can't cross. If you look at the logic of this situation, it's pretty obvious that this isn't true, that part of curve 1 could be below curve 2, and part of curve 1 could also be above curve 2. Just doesn't make sense when we're talking about indifference. Keep in mind here, right, at point B here, we are said to be indifferent between that point and this point, point C. Well, if we're indifferent between those 2 points, how can it also be that we're indifferent between point A and point D? Why is this illogical? Well, because here we're saying B is not as preferred as A, and yet C is more preferred than point D. So how could these 2 points, B and C, be indifferent between each other, and these 2 points, A and D, be indifferent between each other, and yet in one case, curve 2 is less preferred than curve 1, and in another case, curve 1 is less preferred to curve 2. When we look at how the consumer acts, we have to look at them as an optimizing rational creature. And what we're going to do is we're going to have their preferences given by these indifference curves, but then man doesn't just act based on his preferences, he acts within a situation of constraints. So to analyze man's behavior as a consumer, we're going to look at his preferences and then also his constraints. Budget constraints are going to give us this straight line on the indifference curve map. It's going to show us all the possible distributions between those 2 goods. Basically, what can we afford? How many pizzas and how many shakes can we consume? What combinations of the 2 goods can we actually consume given the budget that we have? The budget line provides our constraint. That's the furthest out really we can go. And so what we'd like to be able to see is we'd love to push out this way as far as possible. That's what our preferences are telling us. Notice the utility levels go up as we move further and further out. But what the budget is doing is it's saying this is as far out as we can go. This is the max we can consume. This is our constraint. This is our limitation due to income or ability to consume. And so when we look at utility maximization, we're going to move as far out as we possibly can along these different indifference curves, but we're going to be constrained by this budget constraint. So what we're going to end up with is the slope of the indifference curve is going to be tangent to the budget constraint, so the slopes will be equal here at the point where we're maximizing utility. Why does this end up being the case? Why does it end up being the case that here at point A we are maximizing our utility given this consumer's preferences and their constraints? Well, the utility curves are basically given to us here, the indifference curves. And if we look at it, if we were at some point either B, D, or C, could we make ourselves better off? Certainly we could. Any move in from point B gets us to a higher utility curve. Remember that multiples exist. Any move in from C also does, or any move in or outwards from point D closer to point A makes us better off. We'd be at a higher utility curve. And we keep doing that, and we can keep doing that and keep doing that until there's just one point where the indifference curve touches the budget constraint, such a case as where point A in this example touches the budget constraint, and there we're said to have maximized utility. We'd love to be out here at point E, but the reality is we cannot because we are constrained by our budget, and thus if we're maximizing utility as an optimizing rational consumer, we're at that point where the 2 lines are tangent to each other. That's optimization, where we have the indifference curve just touching the budget constraint. You can try that last example for yourself here on this graph. Here we're doing a utility maximization between hamburgers and French fries. You could see if we were on this original utility curve, you could draw other utility curves further and further out. Obviously we can't draw utility curves further out than any of them where point B is because we are constrained by our budget. So this is a graph that can give you another example to kind of play around with to be able to see it for yourself in a little bit more clear light. A term that's going to matter here when we're talking about the slope of the indifference curves is going to be the marginal rate of substitution. That's really the slope of the indifference curve at a given point. The marginal rate of substitution measures the willingness of a consumer to trade one good for the other. It's measured as the negative of the slope of the indifference curve at any point. At different points along the indifference curve, it's going to most likely be different marginal rates of substitution. Here we see an example of the marginal rate of substitution. If we give up 1 pound of rice a week each, how much do we get in return, or how much do we need to get in return to be indifferent according to these two different characters' indifference curves. So if we look at starting with 4 pounds of rice each week and then we give 1 pound up, if we look at the left curve, Tex's indifference curve, if he moves back 1 unit of rice from 4 to 3 and he gives up 1 unit of rice, he's indifferent between that and 1 more unit of potatoes. Right? But if we look at Mohan's indifference map, if he starts at 4 and then moves back to 3 pounds of rice per week, or units of rice per week, right? How much potatoes does he need in return in order to basically be offset by this transaction of this drop of 1 unit of rice? In order for him to be indifferent between that situation, he has to gain 2 units of potatoes. On this next slide, we can see multiple marginal rates of substitution on one curve. So if we look at the top here, we can see a situation where we have 3 units of food being given up to offset a 1 unit gain in shelter. So in other words, our marginal rate of substitution here is basically 3 units of food for 1 unit of shelter, or 3 in this case. Whereas if we move down the curve, we can see we have different marginal rates of substitution on different points of this curve. So if we move down to this case, where at the very bottom of the curve, we're giving up just 1/4 of a unit of food in order to gain 1 unit of shelter, or to be offset. We need 1 whole unit of shelter just from a 1/4 drop of food. So our marginal rate of substitution here of food to shelter is 1/4 unit of food to 1 unit of shelter, or a 0.25 marginal rate of substitution. If we look at the implications from this, we can see that down here at the bottom of the graph, food is relatively more important to the consumer. So it depends on what quantities we currently have, but this consumer being indifferent here, food is more important because we can see that giving up 1 unit of shelter, or in order to get 1 unit of shelter really, we'd only be willing to give up 1/4 unit of food to get that 1 unit of shelter. Whereas if we're at different quantities, say up at the top, we'd be willing to give up 3 units of food just to get that 1 unit of shelter. In all those cases, really, we're still at an indifferent level of utility. Any of those combinations make us equally happy. And if we look at the other side of the deal, the constraints that we face basically this budget constraint, and this is a too-good world, in this example, food and shelter. And so the only price mechanism that we have really is the cost of food in relative terms to shelter, or the cost of shelter in relative terms of food. So price is really the cost of one good in terms of the other good. And here that's really going to be the slope as well. And so we can get an outcome of being at the optimal point when price is equal to the marginal rate of substitution. Price is going to be the slope of that budget constraint. The marginal rate of substitution is going to be the slope of the indifference.